Okay, I'm going to finish up section 6.2 now. So we talked about the major angles and we computed the trig functions for the four major angles there using the unit circle. And the other angles I want us to look at are some common angles. If we draw an angle in the standard position, that just means that the vertex is at the origin and the initial side is on the positive x-axis. And suppose that we have a 45-degree angle here. I'm calling that angle theta. Point P is where this angle intersects the circle of radius r. And now I've created a right triangle here in this picture. I went x units to the right, y units up to get to that point P. And I've got a 45-degree angle here, like I said, right here. Now, just a general fact about triangles says that when you add all three angles in any triangle, you'll always get 180 degrees. Okay, so knowing that I've got a right triangle means that this third angle here is going to be 45 degrees. We call this a 45-45-90 right triangle. This is one of our special triangles that we see all over the place in trig. Opposite the 45 degrees, I'm going to put 1 just for ease of the calculations. And using the Pythagorean theorem, the sum of the squares of the legs equal the square of the hypotenuse. If you solve, you'll get the square root of 2 as the value of the hypotenuse. Of course, you can't have a negative since you're talking about radius of a circle. The radius can't be a negative there. Okay. We also have a 30-60-90 right triangle, which is another common triangle that we'll see all over the place in trig. So I've got a 60-degree angle drawn here, creating this triangle that is a right triangle, and so the third angle in the triangle is going to be 30 degrees, making the sum of all three angles 180 degrees. And now I've redrawn that triangle over here. And if you think of this triangle as half of an equilateral triangle, and also suppose that each side of the equilateral triangle is going to measure 2 units, then the base of this right triangle would be 1 unit. And using the Pythagorean theorem, I can find that the height of the triangle would be the square root of 3 units. Okay? Now, a 30-60-90 right triangle is a very common triangle that we'll be seeing all over the place in trig, like I said. And in general, you'll always have a 1 opposite the 30, a 2 opposite the 90, and then the square root of 3 opposite the 60. One way that I like to remember this is 30 degrees is the smallest out of a 30-60-90, and 1 is the smallest out of the numbers 1, root 3, and 2, so those need to match. 2 is the biggest number out of the numbers 1, root 3, and 2. 90 degrees is also the biggest angle out of all three of these angles. So those have to be opposites of each other. Okay. I've drawn these three triangles again for when we have a 30-degree angle, a 45-degree angle, and a 60-degree angle in a right triangle. Okay. And I want us to be doing some calculations here with these 6 trig functions. So let's compute sine of 30 degrees. 30 degrees in radian measure would be the same as pi over 6 radians. Remember, you're just multiplying by pi over 180 and then reducing to get that number in radian measure, whatever it was in degree measure. And so, okay, sine of an angle is where we take opposite over hypotenuse. So in this triangle here, opposite the 30 is 1, the hypotenuse is 2, so sine of pi over 6 would be 1/2. Cosine of pi over 6, cosine of an angle, is adjacent over hypotenuse, and so root 3 over 2 would be the value of cosine of 30 degrees. Tangent of 30 degrees, the tangent of an angle is opposite over adjacent, so we'd have 1 over root 3. If you rationalize the denominator, that would be the same as root 3 over 3. Now, just a note, you don't need to rationalize the denominator, at least for what we're doing at the moment. Now, sometimes later on that'll be important to do, but I wouldn't have a problem if somebody were to write 1 over root 3, you know, if we were in class doing this stuff. Cosecant of pi over 6 would be the reciprocal of sine of pi over 6, so instead of 1 over 2, it's going to be 2 over 1. Secant of pi over 6 is the reciprocal of cosine of pi over 6, so that'd be 2 over root 3. Again, you wouldn't need to rationalize the denominator if you didn't want to. And then cotangent of pi over 6 would be the reciprocal of tangent of pi over 6. So it'd be 3 over root 3, or if you rationalize the denominator, 3 over root 3 is the same as root 3. Okay? And then here's a 45, 45, 90 right triangle. Let's compute sine of 45 degrees. By the way, 45 degrees is the same as pi over 4 in radian measure. So sine of pi over 4, opposite over hypotenuse, that'd be 1 over root 2. Okay, cosine of pi over 4 is adjacent over hypotenuse. That's also 1 over root 2, since the opposite and adjacent sides are both 1. Tangent of pi over 4, opposite over adjacent, those numbers are both 1. 1 over 1 is 1. Cosecant of pi over 4 would be the reciprocal of sine of pi over 4, so instead of 1 over root 2, it's going to be root 2 over 1. Secant of pi over 4 would be the reciprocal of cosine of pi over 4, and so instead of being 1 over root 2, it's going to be root 2 over 1 is root 2. Cotangent of pi over 4 would be the reciprocal of tangent of pi over 4. The opposite and adjacent sides are both 1. Okay, so adjacent over opposite, that'd be 1 over 1 is 1. Okay, and then let's look at 60 degrees. You're still working with the 30, 60, 90 right triangle, only angle theta here for this problem is 60 degrees rather than 30 degrees. Okay, and 60 degrees in radian measure is pi over 3. So sine of 60 degrees is opposite over hypotenuse. That'd be root 3 over 2. And cosine of 60 degrees is adjacent over hypotenuse. That's 1 over 2 is 1/2. Okay, tangent of pi over 3 is opposite over adjacent is root 3 over 1 is root 3. And then cosecant of pi over 3, that'd be the reciprocal of sine of pi over 3. That'd be 2 divided by root 3, or 2 root 3 over 3 if you rationalize the denominator. Secant of pi over 3 is the reciprocal of cosine of pi over 3, so it's going to be 2 over 1 is 2. And then cotangent of pi over 3, that's the reciprocal of tangent of pi over 3. Root 3 over 1, when you switch the numerator and denominator, would be 1 over root 3, or root 3 over 3 if you rationalize the denominator. Okay. Now, ideally, this would also be a chart that you'd want to memorize at some point, just like what I had set up here. With this chart and the major angles, okay, because these are just calculations that come up over and over and over and again, and at some point, you know, we'd like to know the values, okay. Now, certainly, if it helps to draw the triangles, draw the triangles, but ideally, you'd want to get to a point where maybe you can just visualize the triangle there in your mind and know what the opposite side is, the adjacent side is, and the hypotenuse is, and go right to the value type thing. Okay. The next thing is I want us to look at angle multiples. Okay, so 30 degrees, 45 degrees, and 60 degrees, those are common angles that are going to come up all over the place. Same thing with multiples of these angles. Okay, so what I mean by multiples is like increments of 90 degrees beyond that, okay? And so I've got, like here's the 45, 45, 90 right triangle drawn in quadrant 1. If I flip that triangle into quadrant 2, then the angle that we would be working with would be a 135 degree angle. And the fact that it's been flipped over into quadrant 2 means that the adjacent side is a negative since you're going to the left of the origin. The opposite side is still positive 1, and the hypotenuse is still root 2. Now, if that triangle is located in quadrant 3, you'd have a 225 degree angle. The fact that it's in quadrant 3 means that the adjacent side and the opposite side are both going to be negative 1, since you're going to the left of the center and below the center. If the triangle were drawn in quadrant 4, you'd be working with a 315 degree angle. And the fact that it's in quadrant 4 means that the opposite side would be -1 since you're going below the origin there. Okay, so pay attention to whether the opposite side or adjacent side is a negative. Now, the hypotenuse will never be a negative. Since you're talking about the radius of the circle, that will never be a negative. Okay, but it's a common mistake for students to forget to have a negative when it should be a negative. Okay. If we want to compute sine of 135 degrees, we would still be using a 45, 45, 90 right triangle, only it's in quadrant 2. The opposite side is 1, the hypotenuse is √2, so 1 over √2 would be the value. Cosine of 225 degrees, well, again, we're working the 45, 45, 90 right triangle. We're in quadrant 3, though. So adjacent over hypotenuse, the adjacent side is -1. The hypotenuse is √2. And tangent of 315 degrees. Okay, tangent of an angle is opposite over adjacent. -1 over 1 is -1. Okay. And then here's a 30-degree angle, or 30, 60, 90 right triangle. And I've got multiples of 30 degrees, or, more specifically, increments of 90 degrees that are, excuse me, it'd be in this case, it'd be just flipping the triangle over into quadrant 2, quadrant 3, or quadrant 4, not necessarily an increment of 90 degrees there. Okay, but so if I draw a 30, 60, 90 right triangle in quadrant 2, that's not going to affect the opposite side of the hypotenuse, but the adjacent side would be a -√3 since you're going to the left of the origin. Okay, if the triangle were in quadrant 3, both the adjacent side and the opposite sides would be negative. If the triangle were in quadrant 4, just the opposite side would be a negative there. Okay, and so here I've got these angles indicated. 30 degrees less than 180 degrees would be 150 degrees. 30 degrees more than 180 degrees would be 210 degrees. Of course, one complete revolution around the circle is 360 degrees. 30 degrees less than that would be 330 degrees. Okay? And if we wanted to, I'm just making up some calculations here. If we wanted to compute like cosine of 150 degrees, here's the triangle that we're using. It's a 30, 60, 90 right triangle, but it's in quadrant 2. So the adjacent side is -√3. Adjacent over hypotenuse, that'd be -√3 over 2. Sine of 210 degrees, you're in quadrant 3 there, so the opposite side is -1. The hypotenuse is, let's see here, the opposite side is -1. The hypotenuse is 2. I think there's I miswrote that. It should be -1/2 there. Sorry about that. -1/2 would be the answer. And then tangent of 330 degrees. Okay, we want opposite over adjacent. That's -1 divided by √3 is the adjacent side. -1 over √3. Okay, and then here's a 60-degree angle. 60 degrees less than 180 degrees would be 120 degrees. 60 degrees more than that would be 240 degrees. 60 degrees less than 360 degrees would be 300 degrees. Again, keep in mind that, if you're going to the left of the origin or below the origin, you're going to have a negative side that is either, the adjacent side of the hypotenuse. Okay. And so I've got these triangles marked out here. All these are 30, 60, 90 right triangles. Okay. And if I want to find like tangent of 120 degrees, tangent of an angle is opposite over adjacent. So the adjacent side is -1 since you're going to the left of the origin. √3 over -1 is -√3. If we want to find cosine of 240 degrees, that would be adjacent over hypotenuse. The adjacent side is negative, so -1/2 is my answer there. Tangent of 300 degrees. Okay, tangent of an angle is opposite over adjacent. The opposite side is negative. -√3 over 1 is -√3. Okay. Now, one thing that I want you to notice here in these problems is notice how I'm giving the exact answers. I hope that when you took trig, whenever you took that, your instructor emphasized giving the answers in exact form. Now, if we were in class, one of the things that I would have done is in this chapter and the next chapter, I would have had no calculator for the assignments, just because for whatever strange reason, students sometimes want to be running to a calculator for things that they really should know using mental math. Okay, trig, I mentioned before, is essential to calculus. And a calc student will struggle because they're not great with trig and algebra. They don't get the basic information there, and that's really the problem for struggling in calculus. It is not the calculus. It's the stuff that they haven't learned before that. So one thing to keep in mind is that when we're giving our answers, we want the answers to be in exact form. Okay, 1 over root 2. If you were to go to a calculator, that would be roughly 0.707 if you go 3 digits out. I see students sometimes write that. They want to, run to a calculator for things like that, and you have a wrong answer now because, of course, the answer is not in exact form. Okay, so please keep that in mind, and that's how they'll want it in calculus. We're just learning the basics of trig now, and of course, we're going to build on the basics. I mean, by that point, after doing things so many times, you don't want to be running to a calculator and getting results that really you should know from, a basic triangle like a 45-45-90 or a 30-60-90 right triangle, the ones that come up all over the place there. Now, there are a couple of calculations in the section where they do want you to use a calculator. Okay, they're very rare, okay, but there are a few. One of the things that you want to pay attention to if you're using your calculator is what the unit measure for the angle is, whether it's degree measure or radian measure. Okay. Now I mentioned that if you're not told, always assume that the angle is in radian measure. Okay. Otherwise, obviously, if you're in degree measure, the degree symbol should be indicated there. Okay. So like if I want to find sine of 58 degrees, well, 58 degrees is not one of my common angles. Okay, it's not an angle that comes up all over the place like 30, 60, 90, or 45. Okay, so I would go to the calculator here, and I want to make sure that I'm in degree mode. I would just simply hit mode, and I'm already in degree mode. Okay, of course, if I wanted to be in radian mode, I'd go over there and hit radian mode. So I'm going to go back to the home screen, and I want to compute sine of 58 degrees. Hit enter, and that's roughly about 0.85 if you go nearest 2 digits. That is an approximation, so the approximate sign would be necessary there. You don't want to use the equal sign, of course, because this is not an exact. Okay, cosecant of 11 degrees. Well, that'd be the reciprocal of sine of 11 degrees, right? So if I compute 1 divided by sine of 11 degrees, I would get cosecant of 11 degrees, which is roughly about 5.24 if you go nearest 2 digits on that. Okay. Here's one more. Okay, we're in radian mode. I'm going to change the mode of my calculator so that it is in radian mode now. You would not be getting the same answers if you were to stay in degree mode here. Okay, so okay, tangent of pi over 12. Let's see, that's so tangent of pi divided by 12. I'm getting 0.27 if I go nearest 2 digits on that. Okay. So again, there's a couple of problems where they want you to use the calculator there, and you'll be approximating answers. Okay, we're not finding anything exact there. Otherwise, be sure that everything is in exact form. That's how the book will want it. That's how I'll want it on the assignments. That's how calc instructors want it. That's how hopefully your trig instructor wanted you to have it before you took this class. Okay, we need the exact answers. All right, that's all I had with section 6.2. And the homework there is on page 389, so you should be able to have a go at those problems for me.